Hello, my name is Rae L. This is my project, my muscle contraction project for Mr. Fraser, period 1. So to start, muscle contraction begins with the brain sending action potential down the axon to the axon terminal, which reacts with these voltage-gated calcium channels. Once that happens, the open channels allow the calcium to enter the axon terminal to react with the synaptic vesicles, and within the synaptic vesicles are acetylcholine. So as it reacts, it releases snare proteins, which allow the synaptic vesicles to cross the membrane, the synaptic membrane. While it's crossing the synaptic membrane, it's releasing its acetylcholine within itself, and the acetylcholine then enters sodium voltage gated channels. And what's happening simultaneously is these neighboring sodium channels are also allowing sodium to enter the membrane, and this is depolarizing, and eventually it reverses the polarity of the muscle membrane, right? And so while it's depolarized, the action potential travels down the sacromella into T-tubules, right? And then after that happens, after this whole process is done, these potassium channels release potassium and repolarizes it. However, after that, or before the potassium reacts, the action potential runs down T-tubules to sacroplasmic reticulum, which houses calcium. And the sacroplasmic reticulum is on top of the thick and the thin filaments. I just drew it separately. And so that's released. It releases calcium here. And now we're just gonna take a closer look at these. The calcium from the sacroplasmic reticulum comes and binds with this tryptophan, which is connected to this tropomyosin. And so this dotted line and this solid line is the same line, just at different stages. So the tryptophan is currently attached to the dotted line, and it more rotates, but it drags the tropomyosin down here so that the actin is more exposed, and it has binding sites that the myosin head can attach to. And so the myosin head, it has ATP, but as it binds with phosphate, it becomes ADP and P. And then the myosin head then has the energy from the ADP and P to bind and like here, let me just put it here, to bind and to bind and drag the actin closer to the center, right? And so while the ADP gives the power to the myosin head to do the power stroke, once the stroke is fulfilled, like that, the phosphate releases and the ADP becomes ATP once again. Except I don't know where oh, here it is. It becomes ATP again, and it releases. And then the process continues. So as the myosin head is dragging, it's not dragging the thick myosin, it's dragging the actin closer to the center. And so once the thin actin meet other thin actin, like this, the contraction is done, the myosin head returns, the calcium releases from the tryptophan away back to the sacroplasmic reticulum. This rotates back, allowing the tropomyosin to cover the actin again. And so once this the tropomyosin is covering the actin again, and the myosin head has returned, from the center, the thick actin then comes back to its original placement, and the contraction is complete.